Okay, welcome back to our Algebra 2 lessons here. This is Chapter 2, Section 3 from Big Ideas Math. Last time we were graphing the standard form, vertex form, and the intercept form of parabolas. And today we are learning a new form because we are going to talk about a new part of a parabola that you maybe don't even know about, and it is called a focus. Okay, so here we go. Parabolas we've been dealing with so far have opened up and down, and you're probably even used to that from taking Algebra 1. You've maybe never seen a parabola that opens right and left, but today is your lucky day. So, there is a standard equation for a vertical axis parabola, and that is y equals 1 divided by 4p times x squared. And a vertical axis of symmetry parabola basically is one that opens up or down, so that has the vertical axis as its axis of symmetry. So in this case, it's just the y-axis. Now, the horizontal axis of symmetry, those are the ones that are opening to the right and to the left. And as you can see, the x-axis is the axis of symmetry. Important things to note right now is x squared parabolas open up and down. Y squared, whoa, check that out. Have you ever seen that before in your life? Y squared parabolas are the ones that are going to go ahead and open right and left. So that's the first thing you want to think about. And then now you have this thing called the focus. The focus is actually really important. And what I need you to look at in every single one of these pictures is that the focus is always on the inside of the curve. It's on the inside. So I'm going to say the focus is in the dish. And I say dish because I'm going to draw you a nice little picture here. There's a satellite dish on almost every house in my neighborhood. And satellites are parabolic shapes. So this exists in real life. When am I ever going to use this? Well, guys, you have satellite TV. You are using it. You are using it right now, maybe. And the focus is important because what happens is the information comes in to the dish, bounces off the side, and bounces back out again. Information comes in, bounces out, in, bounces out, comes in and bounces out. Where do you notice it's always bouncing through? It's the focus. That is the focus of information. Just like how when I tell you, okay guys, focus, you need to concentrate here. Well, the information's coming into the satellite and going straight through that focus every time. Okay, have your cheat sheet in front of you because here we go. It says identify the focus, the directrix, and the axis of symmetry of negative 4x equals y squared. Then graph the equation. Alright, something important needs to be happening in your head right now. You've got y squared. And because you have a y squared, you know that that means you're going to open either to the right or the left. Alright, so standard form is x equals 1 over 4p y squared. So for our problem, we have negative 4x equals y squared. We need to go ahead and divide by the negative 4. And we're going to get x equals 1 over negative 4y squared. I find it's easiest to just set up a proportion here. So I'm going to say 1 over 4p is equal to 1 over negative 4. Cross multiply, that's 4p. Cross multiply, that's negative 4. Divide by your 4. P equals negative 1. All the way back at this first step over here, could you have identified that it was negative 1? Probably, but I'm just showing you how we got there. So P is negative 1. Well, why is P important? Let's go back here for just a minute. Let me grab my eraser. P is actually representative of the distance between the focus and the vertex. See that? P is the distance. P is the distance. Okay, so let's go back to our problem here. We're going to have our vertex at 0, 0 like they told us to, because that's standard form. P is the distance. So P here is negative 1. Now, I'm not going to go down though, because remember it's a y squared, and y squareds go to the right or to the left. So I'm going to go right here, say that that's my focus. I'm just going to wing it that it opens how it goes, like here, like so. Okay, so our axis of symmetry then is actually y equals 0. Our focus is, where did we put that focus, guys? Where did we put it? We put it at negative 1, 0. And then the directrix, now let's come back here because I haven't said that word yet. The directrix is the line equidistant to the vertex on the outside of the parabola. See that? Okay, let's come back to our problem. So in our case, it is the invisible line that's right here. And it is going to be x equals 1. So there's something I want you to notice. Let me grab my highlighter. What I want you to notice is that if it is an x equals equation, it's an x equals directrix. And that also means it's got to be a y squared, which is to the right or to the left. Okay? Make sure you're asking questions, but let's go ahead and try another. It says write an equation for the parabola shown. Alright, well, we got to count, and I know you can do it. Here's our vertex, and we're going to go 1, 2, 3. So, from the vertex to the directrix is 3 units. Now, which way is this opening? Up, down, right, left. It's down. Okay. Down means it's x squared. So you should be thinking y equals 1 over 4p x squared. And if the directrix is 3 units away, then so is the focus. So let's go the other direction then. 1, 2, 3. Here's the focus. What is that point? 0, negative 3. Okay, so we have our focus at 0, negative 3. What's the p-value then? Go to your cheat sheet if you need to. P should be negative 3. So you plug that value in there. Going to change colors. Y equals 1 over 4 times negative 3. x squared. So y equals 1 over negative 12 x squared, or negative 1/12 x squared. Done. Okay, let's try some more. It says identify the focus, directrix, axis of symmetry, graph it. All right, number 2, y equals 0.5x squared. So you're thinking it's an x squared, which means it's up or down. And it's 0.5, which is positive, so we're going up. We're starting here at the origin. 0.5 is actually 1/2. 1/2 x squared, remember, is equal to 1 over 4px squared. So set those two parts equal to each other. 1 over 2 equals 1 over 4p. Go ahead and do your cross multiplication. You get 4p equals 2. That means p is equal to 2 over 4, or 1/2. So we're going to go 1/2 up for the focus. So 0 on the x, 1/2 up. The directrix is 1/2 down, and the directrix is y equals, so it's negative 1/2. And we're just going to wing it here for our parabola and just say it opens like this. We're not actually checking points for this lesson. So focus, got it. Directrix, got it. Axis of symmetry. Okay, the axis of symmetry for this problem, we'll use green again. Bammo right here. The axis of symmetry, x equals 0. Whoops, I'm trying to write 0 and it's not letting me. There we go. All right, number 3, negative y equals x squared. Well, first and foremost, you need standard form. And remember, that is going to be equal to 1 over 4p x squared. Because it's an x squared, you're opening up or down. Because it's negative, you know you're opening down. So you have negative 1 equals 1 over 4p. Well, you can put a 1 underneath the negative 1 to make your proportion easier here and get negative 4p equals 1. Still having problems with my pen. And so p is equal to negative 1/4. All right, get your vertex on there. That means the focus, as at 0, negative 1/4. The directrix is at y equals 1/4. It's opening down. The axis of symmetry is x equals 0. All right, let's try the next one, number 4. It's a y squared. So you should be thinking, hey, this is going to open either to the right or to the left. All right, let's see if I can change my line style again. So first things first, we got to solve. So it's 1 over 6y squared equals x. I divided both sides by 6. Remember, the formula is 1 over 4p y squared equals x. So you're going to set 1 over 4p equal to your 1 over 6. Do your cross multiplication. You get 4p equals 6. Unless your pen's messing up. There we go. Divide by 4, divide by 4. P equals 3 halves. Now, it's a y squared, guys. What's that mean? It means we're going to open either to the right or the left. So we're going to go 3 halves to the right for our focus. So our focus is at 3 halves, 0. And it's going to look like that. Our directrix is going to be at negative 3 halves. X equals negative 3 halves. And going for green again, axis of symmetry, y equals 0. Okay, here we go. We've got some given information we're going to use to figure it out. Our vertex is at 0, 0. Our directrix is x equals negative 3. Remember, an x equals line is a vertical line. Now you can count how many units is it to go from here to here. How many units is that? 3 units, right? So that means we're going to go 3 units this way, but our focus, because our focus is always in the dish. So our focus is always in the dish. And then the directrix is the house. Like, the dish isn't going to cross over into your house. It's on the outside. So see how it's pointing away from the directrix? That always happens too. Okay, so now they want us to write an equation here. Well, clearly, this is opening right or left. So it's 1 over 4p y squared. And what is the p value? We already found it, even though we didn't really find it. You should know what it is, because it's the distance here, or the distance here. And what is that? It's a 3. So you're going to substitute a 3 in for the p. So you get x equals 1 over 12 y squared. All right, let's do some more. This is fun, huh? Okay, here's my vertex at 0, 0. My focus is at negative 2, 0. Hey, remember the focus is always in the dish? So the focus is in the dish. This is opening right, left. So it's actually opening left. That means the directrix would be over here, which I don't even need this time, because they're not asking me to graph it. It's just graphing it makes it easier to identify which way it's opening up. Okay, so if the focus is in the dish, it is opening to the left. This is going to be an x equals 1/4. I know p is negative. I know it's negative because it's left. And if I count here, how many units are between my vertex and my focus? You should have 2. So our final answer would be x equals 1 over negative 8 y squared, or you could say negative 1/8 y squared. Yay, last one. I've got my vertex. Focus, it says, is at 0, 3 halves. So that's right here. Focus is always in the dish, guys. So that means this guy's opening up. Up is going to be a x squared, so I've got y equals 1 over 4px squared. What is the distance? Right here, the distance from the vertex to the focus. Well, it's 3/2. So we're just going to have a little bit of math here, but we can handle that. It is math class after all. 3/2 in there. X squared. Okay, so what is 3/2 of 4? Well, 4 times 3 is 12, and 12 divided by 2 is 6. So I get y equals 1/6 x squared. Okay, now we need to shift it. We're going to have some translations here, just with our h and k's like we have before. Okay, but there is a trick. There is a trick for sure, because the h's are always with the x. All right, look up here. H is in the x spot. K is in the y spot. X's and H's, they're like best friends. And Y's and K's, they're like best friends. And so they stick together. Now the reason that's important is because you are not just opening up and down anymore, are you? No, no, no. Now you're opening right and left. And when you open right and left, it is the y that is squared, like we've already talked about. But that is important. Let's see if I got my line. That's better. That's important because k's like y's. So it is the k that is on the inside of the parentheses here. Okay, so I can explain that as we work, if that's confusing to you. Here we go. Here's our first one. It says write an equation of the parabola shown. The first thing you should notice is that we are opening to the right. So it's right left. So it's x equals 1/4 p. It's y minus k quantity squared plus h. Okay, now that means you have to identify the vertex. So what is the vertex? 2, 4, 6, and 2. Okay, 6, 2 is our vertex. Now, the focus is how far away? What is that distance right there? 4 units. Okay, so now we're going to plug in what we know. X equals 1/4. What was the p-value? We counted, it was 4 units. Y minus, what's the k-value? It's 2. Quantity squared plus, and what's the h value? It's 6. Okay, now all we have to do is simplify, and I get x equals 1/16 times the quantity y minus 2 squared plus 6. Not too tricky, as long as you remember that the y's and k's stick together, the x's and the h's stick together. Alright, an electricity generating dish uses a parabolic reflector to concentrate sunlight onto a high-frequency engine located at the focus of the reflector. The sunlight heats helium to 650 degrees Celsius, that is hot, to power the engine. Write an equation that represents the cross-section of the dish shown with a vertex at 0, 0. Okay, the nice thing here is vertex at 0, 0. That means we know we have y squared equals 1/4 p x squared, because x squared faces up. This is obviously facing up. All right. First things first, they gave you this 4.5. That is the distance from the vertex to the focus, so it's the p-value. So 1/4 times 4.5 x squared. What is 4 times 4.5? y equals 1 over 18x squared. Okay, there is our equation. Now the question. What is the depth of the dish? Well, the depth of the dish is right here. Right here at that y value, whatever that y value is. Where can we find that y value? We can find it at this x value. So the question is, what's that x value? If the whole length is 8.5, then I need half of the length of 8.5 because that's going to be the x. So that's 4.25. So you're going to take 4.25, which is that x value. You're going to plug it in over here. Just use your calculator. And you're going to find it's approximately 1. 1 what? Meter. 1 meter. All right, last problem, here we go. A parabolic microwave antenna is 16 feet in diameter. Write an equation that represents the cross-section of the antenna with its vertex at 0, 0 and its focus 10 feet to the right. Okay, that is important. So stop right now. Vertex at 0, 0, 10 feet to the right. The focus is always in the dish, which means this is a y squared. Okay, after we write the equation, we're going to find the depth of the antenna. You can draw a fancy picture if you want, but we really have what we need. So let's go ahead and get started here. We already said it's going to be y squared, so it's x equals 1 over 4p y squared. What is the p value? What is the distance to the focus? Right here, 10 units. So that's 1 over 40y squared. All right, equation done. Now, it says that the parabolic microwave antenna is 16 feet in diameter. So, maybe it would help you for me to clean up my picture a little bit. That's your 10 right there. And then this from here to here is your 16. That's funny, huh? I told you I was going to clean up my picture. All I did was make a mess. But hopefully you watched as I drew it so you can see what we're talking about here. And I'm going to plug in what value? Do I plug the 16 in there? No, I really don't. If I want to know the depth of the dish, I'm going to come out to the edge here to find the depth of the dish. 8 units. So 1 over 40 times 8 squared is 64 over 40. Grab your calculator. And you should get 1.6. And what is it? It is feet. All right. Great lesson. It was another long one, so hopefully you stuck with it. I hope you're having a great day. Go ahead and get started on your practice work.